All right, so what we're going to do is we're going to go through the process that we talked about a little bit yesterday of making our line segments for our picture project. One of the reasons I wanted to make a separate video so that I could reuse it and replay it for you, and it's a little bit clearer sometimes than WebEx usually is. So what I'm going to do is basically go through the idea of the project. So I'm going to start with just by making a picture. And guys, I'm not trying to make any certain special kind of shape or anything. I'm just going to show you the idea of what you're supposed to be doing. So I've made my picture here. You can see my pretty little lines. That one's supposed to be vertical. It's a little bit off. So I've got my shape here. I'm also going to do another line over here that's kind of steep away from the origin because I want to show you something that you'll have to consider when you're doing your own picture. So it doesn't matter to me whether you want to label these with numbers or with alphabet letters. I do not care. I personally would use numbers just in case I'm planning on having a shape that's bigger than 26 lines, which you have to have a minimum of 25, so it's probably a good idea to use numbers. But notice I've labeled my lines. What I'm going to do then is on a separate sheet of paper, I'm going to come over and I'm going to write down number 1, and then I'm going to find my equation. Okay, and I don't care if you put all your work there, as long as you show me your final answer somewhere, that's fine also. So I'm going to come over to my equation, and I've got this point right here, and this point right here is the ends of that line. We talked about the endpoints a lot yesterday. So we've got -4, -2, and then we also have -1, 5. And so then I take, sorry, not -5. I'd use my slope formula. I'm going to go y2 minus y1 over x2 minus x1. And I'm not going through this slowly because at this point, if you are still having trouble finding the slope, you should get some help from me, or you should find some extra videos online that go through the slope a whole lot slower than I am. So 5 minus -2 is a +7. -1 minus a -4 is same thing as -1 plus 4, so that's 3. So my slope is 7/3. And if you count this, you should see that it goes up 7 over 3. You can see that it does that. So it's a little bit ugly slope here. Then what I use is I use my slope, and one of these points, I would probably use -1, 5 to use my y equals mx plus b, plug in my y value, plug in my slope, plug in my x value, and then I find b by doing
We have maybe the possibility of putting 3 rivers
Wow.
into 1 or 4 rivers into 1,
sorry.
but you don't have the opposite.
My YouTube decided just to play all of a sudden. That was weird. All right, let's come back to here. All right, so 7/3 times -1 is -7/3. We're going to solve this equation. And then you have 5 over here, so we add 7/3, add 7/3 to this side. It cancels out and leaves me with b equals 5 plus 7/3. 5 plus 7/3 is going to be, let's say 15/3, and 7/3 is 22/3. Or 22/3 is about 7.3. If you look at your graph up here and you continued this line up this way, you would see that it does cross up here somewhere around 7.3. Obviously, we don't extend the line out. I'm not telling you to extend the line out. I'm just showing you that's what it would do. So then I would come over here and I'd say y equals 7/3 x, my mx, plus b, 22/3. You can also use Word if you would like, or Google Drive. Google Documents even does this. It's a little bit, Google Documents is a little uglier in my opinion to work with the equation, but it's very similar. But you can type in an equation into Word. You can say line number 1, and I can hit Alt equal, and it opens this equation tool, and I can type in y equals, and then I can go 7/3, and I believe if I do 7 divided by 3 and hit space, it'll change it to a fraction for me, x plus 22 thirds, hit the space button again, and then that gives me my equation. So I could type that into a Word document or even into Google Documents, and it would make it really nice and pretty for Mr. Harrison to read. Now, I'm not saying you have to do that, but it definitely would make it a lot easier on me if you did type it in. It'd be nice. Not a requirement. If you just write it down like this, Mr. Harrison can read bad handwriting. He reads his own handwriting, right? So, now we're going to take a look at the domain and range. Remember yesterday we talked about this is not a full line, it's a line segment. So the domain and range means I need to take and I need to say, okay, it goes from -4 for this x value to -1 for this x value. That would make my domain -4 up to -1. Remember what you're basically doing is you're saying the starting x value to the ending x value. Now we go from left to right with the x's. You go from bottom to top with the y's. So the starting y value down here is -2. The ending y value is 5. Now the tricky part about the y's a lot of time is that even if your line is going down, you have to start with the lowest number and go to the highest number. That's the way these inequalities work. They start with the low number and go to the high number. So be careful with that. Just know that that's going to be kind of weird a little bit when you do the y values from time to time. But guys, essentially what you're doing is you're telling somebody where to end the lines, where to start them, where to end them, and you're telling them what the x values are and what the y values are. Don't overthink that domain and range. If you are the type of person who does want to make it neat and you want to type it up, you can come back over here to your equation where you've got this and you can say, skip a few spaces maybe and hit domain. And then you can go -4. Then there's a less than or equal to up here at the top of the screen. X less than or equal to -1. Then you can go a couple more spaces, range. Then you can hit, -2 for our y values, up to +5. And so I'm again using this little less than or equal to up here. Like I said, I think the equation editor in Word is a little bit easier to use than Google Docs, but it's about the same. So then I can just press enter, and then I can just go to line number 2. And now I'm ready to type in the next one. So let's go to line number 2 on our graph. Line number 2 on our graph is a horizontal line. Now the reason I gave you some of these that are horizontal lines and vertical lines is because you'll notice that it makes it a lot easier, because all I have to do, if you remember from yesterday's class, or if you watch yesterday's class and you need to go back maybe and watch it, a horizontal line like this at 5, because it's 5 the whole time, is just going to be y equals 5. I don't even have to do any work to find the equation. The equation is already staring at me. The domain is the x values, and remember it starts at -1 right here, and then it keeps going to here, which would be +1. So that's -1 up to +1. The range for a horizontal line is never going to change because it's y equals 5 the whole time. You don't have to write the range for a horizontal line, so if you don't write the range, that's okay. Again, you can go to your Word document if you want to use that. Alt equal y equals 5. Skip a few spaces, write the word domain, and then I'm saying -1 up to +1. And my range is y equals 5. Range doesn't change. So if you leave off the range and you don't type in the range for that one, Mr. Harrison can pick up on that. He's dealt with horizontal lines enough to know that the range really doesn't change on a horizontal line. When you get to line number 3 is a vertical line. So I do understand that that one's going to be a little different too. But a vertical line, remember, is the same x value the whole time. All right, I'm going to come over here just to save a little bit of space here. Line number 3 is a vertical line. X equals 1 the whole time. So what that would do is that would make my domain be 1 the whole time. But my range would change. The range would be from -2 down here up to 5. Be careful, make sure that you pay attention to the lowest y value up to the highest y value. So -2 up to 5. So I could come over here again to my Word document and I could type it in. All right, we got Alt equals, that's the Alt button by the way, I'll say it again, X equals 1. My domain will not change. It'll be X equals 1. So if you don't want to write the domain for a vertical line, that's fine. The range, however, will change. It'll be -2 up to 5. And so then I'm ready to go to line 4. And I just keep going through this process for my entire project. And the reason I told you, horizontal and vertical lines here is because if I'm looking at these horizontal and vertical lines, like this one's y equals -2 the whole time, my domain is going to be from -4 up to 1, because it's -4 over here over to 1. And again, guys, the reason that happens is this point right here is -4, -2. This point right here is 1, -2. Notice my y value doesn't change, but my x values go from -4 over to 1. So that's one of the reasons that I use just the domain. But if I want to write the range too, it's okay. The range is just going to be a repeat of my equation because the range is -2 the whole time. So that's fine. You can write both of them, or if you just write the domain for horizontal and the range for vertical, that's fine. But the reason I told you I wanted you to be required to do at least 10 slanted lines is because I want you to have this experience that we have over here of actually getting the slope and getting the y-intercept. You need to be able to do that for a line, and that works even in applying some of the real-life applications problems that we practiced earlier this week as well. So you need to be able to do that. But horizontal and vertical lines are really nice when it comes to this project. So I'm not saying you can't use those. Like I said, you got to have 25 lines. 10 need to be slanted. So the other 15 can be horizontal and vertical. So it does make those a little bit quicker. All right, the last thing I want to do is I want to focus in on this little slanted line right here that's kind of far away from the origin. Think about what that means. That means way up here somewhere is going to be where it hits the y-axis eventually. So what that means is when you look at line number 5 here, your points that you're going to use, you're again wanting to use your endpoints if you can. Now, like I said, you don't have to have perfect endpoints. I told you this yesterday, but it really does help as far as finding your equation. So my endpoints here on this one are, what's that, -8, 4, and then -7, 8. So if I find my slope of my line here, I'm going to do my y2 minus y1, x2 minus x1, 8 minus 4 is 4, -7 minus a -8 is the same thing as -7 plus 8, which is 1. So this is just 4. And if you look at your line, it's going up 4 over 1. Up 4 over 1. That's what the slope actually is. But here's the reason I wanted to show you this one. This one, when you go to find your b value, when you use your y equals mx plus b and you pick one of these points, I personally would pick the point -7 and 8. So I'm going to plug in 8 for y, plug in 4 for m, plug in -7 for x, and then I'm going to find my b value. Watch what happens here. You're going to get -28 when you multiply 4 times -7. And then you're going to add positive 28 to 8. That's going to give me 36 for my b value. That means my equation is y equals 4x plus 36. Now, some of you might panic and go, oh my goodness, that's a gigantic y-intercept. What? I did something wrong. No, just think about where that line is. It's far away from the origin, and it's really steep, so it's going to not hit the y-intercept until 36. It's going to be way up above the graph before it hits it. That's why you can't count on your eyes to help you figure things out. You actually need to know how to do the math to figure out the b-value. Last thing I'll show you on this, and then I'll be done, is the domain for this one goes from -8 to -7. The x values are the domain, and then the range, the lowest y value is 4 up to 8. The y values are the range. Sorry, messed that up. All right, so basically, guys, this is the idea of what you want to do. Like I said, you can write it out by hand, and you can type it if you wanted to. That'd be a lot prettier, easier for me to see. But you're going to turn this in. You're going to make your picture. You're going to label it. You're going to find your equations and your domain and range, and then you're going to turn it in as sort of a little folder, a little portfolio. You can either use something like, you can go buy something cheap at CVS or something like a little clear cover portfolio. Your cover page needs to be a colored version of your picture. Then you need to have your labeled picture with your labeled numbers on it, and then your labeled set of equations, kind of like I did right here, except I put it all on one page. I would prefer that you put it on separate pages. Also, I make sure that you use graph paper, obviously. I think that's self-explanatory, but you can't just count on your own artistic skills. Mr. Harrison could not draw straight lines without graph paper, probably, right? Use a ruler, too. That'll help you out. So, if you got any more questions, definitely I'll be on WebEx during our class times. I'll be playing this video, but then I will be available to answer questions, and I'll be available after lunch as well. And I can probably be available also sometime this weekend to help you out if you have any questions, maybe Sunday afternoon or something like that, if you have any questions for me. Good luck, guys. I hope your projects turn out really well. I'm excited to see the different types of pictures.